More conversion problems. A, we're turning 157 centiseconds, not a very common unit, to seconds. Seconds is the base unit, so all we need is one conversion factor. We need to set it up to get rid of centiseconds and end up with seconds. So centi means 100 times smaller, so there's going to be 100 centiseconds in 1 second. Just dividing by 100, so it's 1.57 seconds. B, 42.7 liters to milliliters. All right, we're going from the base unit to one with prefixes. Again, just one conversion factor, it will do. But the liters in the bottom, we get rid of the liters we start with and the desired unit on the other side of that. Milli means 1,000 times smaller, so 1,000 milliliters in 1 liter is the equality there. All right, so this time we're multiplying by 1,000. So 42, that decimal 0, move it 3 times, 1, 2, 3. So 42,700 milliliters. Now, I don't like leaving zeros here, even though we know that they're not significant. So you can rewrite this in scientific notation. All right, that's 1, 2, 3, 4, and turn that coefficient into 4.27. And now we know the 4 and the 2 and the 7 are significant, and there are no zeros in my scientific notation, so that means these zeros are not significant. Times 10 to the 1, 2, 3, 4 times is how many times we moved it. So that's just how I would write it. See. Now here we have a conversion where it's going from one prefix to another. So whenever we do that, I advise you to go from one to the base and then back base to the other. All right, so make a stop at the base. So we'll need two conversion factors here. So 261 nanometers, and then let's take that to the base. All right, so nanometers to the base unit is meters. All right, so in 1 nanometer, a nanometer is a billion times smaller, so it says 10 to the negative 9. And so nanometers cancel out. Now we can go from meters to millimeters. All right, so meters needs to be on the other side of our conversion factor, and the desired unit on the other side of that. Again, milli means 1,000 times smaller. And I'm switching up the method here. So if you just want to use all the same way for all these conversion factors, like this is just natural to me. And that's centi, milli, or a kilo, and some of these are just I just like use it every day in everyday life. Is I just use it like that. So, but if you want to do it one method every time, you can always put 1 next to the unit with the prefix, like millimeter or nanometer or whatever, and then put that equivalent in millimeters, 10 to the negative 3. So you can always do that, and then every time you do one of these, it'll be the same way. It's just that, yes, I'll just do it that way for this one, 10 to the negative 3. So whether you do that, or whether you wrote 1,000 millimeters, which is what I normally do, 1 meter, you're going to get the same answer. Okay. All right. So we're gonna. This might actually make it a little easier to do the computation. All right. So we can bring different shade of green. We can bring this number to the numerator by switching the sign of the exponent, right? And then that'll give us 10 to the 3. Now we're just adding 10 to the negative 9 plus 3, because they have the same basis. We just add the exponents, and that's going to give us 10 to the negative 6. All right, so the answer is 261 times 10 to the negative 6, and the unit is millimeters. Now, can't leave it like that because that's not proper scientific notation. So we'll gotta move that decimal that way over twice, and we're going to increase that by 2 by doing that. So it's going to be 2.61 times 10 to the negative 4 or millimeters. Did I say nanometers? I meant millimeters. All right, now if you have a calculator, I'm sure you do, and you want to just punch all these numbers in and do it that way too. This is just faster when we have tens, ones, and zeros, and just sometimes faster to not use a calculator. But yeah, definitely use it if you're more comfortable with that. All right, here we go. So here we go, another prefix to another prefix. So stop by the base here, right? Meters is the base unit there. Kilometers and decimeters. All right, 0.065 kilometer. Let's get rid of kilometers and turn that to the base unit as meters. So there's 1,000 meters and 1 kilometer or kilometer. All right, now we can go from meters to decimeters. Deci is 10 times smaller, so there's 10 of those in 1 meter. All right, so we're just basically moving this decimal over 1, 2, 3, 4 times. Right, so 1, 2, 3, 4. 650 decimeters. Right, because you're just multiplying by 10,000. You're multiplying 0.065 by 1,000 times 10 is 10,000. And again, you got that 0 at the end, so if you want, you can rewrite this as 6.5 times 10 to the 2 decimeters, and then there's no confusion whether that's significant or not. Right, need a copy and paste because I'm running out of room. Okay, stick E down here. All right. 642 centigrams. All right, again, prefix, make a stop at the base unit, in this case, grams. All right, so centigrams to grams. Try that again. All right, centigrams goes on the other side of the conversion factor to cancel it out. The desired unit goes on the other side of that. Centi means 10, means 100 times smaller. Here we go. Get rid of grams, other side there, and the desired unit is kilograms, so I'll put that on the other side of that, and there's 1,000 grams in 1 kilogram. Kilo means 1,000 times bigger. Okay, so now we are going to just divide by, and we're going to make this 1, 2, 3, 4, 5, 6 times smaller. 1, 2, 3, 4, 5, 6. You know what, I'm just going to use my calculator. I feel like I went too far to make a mistake. Yeah, here we go. Calculator, get rid of that. 542 divided by 100 divided by 1,000. No, I was right, but want to make sure. So 0.00642. All right, kilograms. And since we got a bunch of zeros on the left, we could pretty this up a little bit and write it in scientific notation. 1, 2, 3 times smaller, so it's -3. Oh, hold on. Can't be making mistakes already. All right, there we go. All right, and we got one more. F 8.25 times, this one's written in scientific notation, and the unit is centigrams. All right, centigrams to another unit with prefix. Again, stop by the base unit and then take it all the way. Even though centi and nano are on the same side, like they're both smaller prefixes that scale the base unit smaller. You know, like centi's here and hold on. Like here's the base, here's deci, here's centi, here's milli, here's micro, here's, you know, I will still go to the base and then go back down. All right, go to the base. That's what I'm trying to say. You know, when I'm out of space, you'll see a magic trick. Never mind. All right, here we go. Let's do this problem. Centi to the base. Man, what are we doing? Where did my question go? Did I erase it? Oh, here it is. Up here. Sorry. Centi to nano. So we're going to get centi down here. I'm going to go to the base. All right, go to the base always. So centi means 100 times smaller. 100 centigrams and a gram. That was my cat. All right, and now we can take it to nanograms, put grams down there, and then nanograms up here. Nano is 1 billion times smaller. So this is where I flip the method here. I always put the 1 next to the one with the unit with the prefix, and then I'll use 10 to the negative 9 for billion times smaller than the base. All right. Do we need a calculator? We don't need a calculator for this. These are easier without one. So this one is just going to be 10 to the 2, right? 10 times 10 is 100. All right, we're going to go switch it up here. We're going to go multiply these numbers. So you're going to add the exponents. So these two numbers combined is going to give us 10 to the negative 9 plus 2 is negative 7. And now this number is on the top, this number is on the bottom. So numerator and denominator, we're dividing. So that just means subtracting. So that's going to be 10 to the 2 minus a negative 7. So 2 plus 7 is 9. So our final answer is going to be, have the 10 to the 9. Well, maybe not our final answer. It is our final answer, right? Because the coefficient is already a number between 1 and 10. So I just copied that part over and I just did everything else is just 10 and the exponent changing. All right, and then the unit is nanograms.